Welcome back to Advent of Code 2018, day 24, Christmas Eve. Second last day of the Advent, and tomorrow will be Christmas Day. Oh, if I finish 24 shortly, then I might actually move straight on to 25. Get this done, then I can at least have a break of one day before I have to start the actual 2023. That would be nice, wouldn't it? All right. Then let's try and get this done quickly. Is there a problem? Seems to be hanging. I think the site is... Okay, there we go. Immune System Simulator 20XX. So what have we got here? After a weird buzzing noise... Well, this is a YouTube video. Wow. I actually remember that noise, and it's been so long since I played Myst, and I'm due to play Myst, like the remaster, at some point in the coming months, years, decades. Okay, you appear back at the man's cottage. He seems relieved to see his friend, but quickly notices that the little reindeer caught some kind of cold while out exploring. Do reindeers catch colds? Probably they do, actually. The portly man explains that this reindeer's immune system isn't similar to the regular reindeer immune systems. The immune system and the infection each have an army made up of several groups. Each group consists of one or more identical units. The armies repeatedly fight until only one army has units remaining. Units within a group all have the same hit points, attack damage, an attack type, an initiative, and sometimes weaknesses or immunities. Here is an example group. 18 units each with... Wait, how is it going to be worded? Oh my god, okay. Might actually want to use regular expressions here, but then you got the... Okay, fine. Each group also has an effective power. You can actually manually enter these, but I'm not. I'll use like regular expressions. Effective power. The number of units in that group multiplied by their attack damage. The above group has an effective power of that. If you have 0 negative units, you get removed from combat. Okay. Each fight consists of 2 phases, target selection and attacking. During target selection, each group attempts to choose one target. In decreasing order of effective power, groups choose their targets. In a tie, the group with the higher initiative chooses first. The attacking group chooses to target the group in the enemy army to which it would deal the most damage. Fine. There's a lot of stuff, but it's not. None of it's particularly complicated. Difficult. It is complicated. If an attacking group is considered two defending groups to which it would deal equal damage, it chooses to target the defending group with the largest effective power. Alright. And then you go by initiative. Okay, fine. If it cannot deal any defending groups damage, it does not choose a target. Defending groups can only be chosen as a target by one attacking group. Fine. Each group has selected 0 or 1 groups to attack, and each group is being attacked by 0 or 1 groups. Goodness, alright. During the attacking phase, each group deals damage to the target it's selected. Groups attack in decreasing order of initiative, regardless of where they are. Got it. Alright. Oh man, okay. The damage an attacking group deals to a defending group depends on the attacking group's attack type and the defending group's immunities and weaknesses. By default, an attacking group would do damage equal to its effective power to the defending group. However, the defending group is immune to the attacking group's attack type. The defending group instead takes no damage. The defending group is weak, takes double damage. The defending group only loses whole units from damage. Damage is always dealt in such a way that it kills the most units possible. And any remaining damage to a unit that does not immediately kill it is ignored. So you basically divide by the hit points and round down. Okay. Got it. After the fight is over, if each army's deal still contain units. So damage... Okay, fine. Combat only ends once one army has lost all its units. Okay. Well, we've got a fair bit to code here, but it's not too bad, I guess. Alright, how do we get started? We just gotta do it step by step, so let's start with... pausing the input. Alright, so... weak to... Oh man, it's the semicolons separating the immunities and... Okay. So I guess we want to define a group class. Right. A group is, well, it has, this might be a good opportunity to use the data class. I can't remember how to use it. Data classes. Damn it, let's just look it up. I don't know how to use data classes. Okay. Okay, we've got units int hit points int. Weaknesses list. How do you do lists? You just list string. Is that correct? Okay. Immunities list string. Why is the computer slowing down so much? What's going on? This PyCharm indexing stuff, it does that sometimes. PyCharm is using a lot of RAM. Why? Microsoft Edge. Why do we have Microsoft Edge open? What was that? Okay, whatever. Immunities. So attack int attack type string initiative. int. That's what we need. Okay. So effective power. Define get effective power. Turns, it's going to be number of units multiplied by attack damage. Okay. It's variable. Hello, Blaze Labs. What is Advent of Code? Advent of Code is this website here. I'm doing specifically 2018. Basically, every Christmas, every December, at least these years so far, we have one problem released each day of the month, up to 25. They start off quite easy, then they get a bit harder. So it's just like a free-for-all kind of community-driven. I hesitate to say competition because it's not very competitive. There is a leaderboard, but only for the top 100 people. But in general, people just do it to just try and complete each problem. It teaches you about coding, about like some software engineering skills, a bit of maths as well, stuff that's useful to a programmer. It's accessible to beginners and experts alike. There's something for everyone. Like beginners can get the first few done at least. You can use any language you want. And there's like forums where you can discuss with people how you solved it and stuff like that. It's really, I'd say it's the best website of its kind right now. I don't know of any better ones for this kind of purpose. So yeah, it's good. It's made by one guy called Eric Wastel. He turned up in my chat once while I was streaming one of these. I'm trying to do the archived years, so I'm trying to finish up 2018. But these ones I did live. I did 2020 live and I did 2022 live. 2023 will open in 2 days' time. So you can actually participate if you want on December the 1st. But you don't have to complete it on the day. Reminds me of Project Euler. Yeah, it is a lot like Project Euler, yeah. But it's more of a timed thing, so everyone does it in the 25 days of December. Of course, you can do it any time afterwards. It's all archived, but a lot of people do it together, so that's it feels a bit more community-driven than Project Euler, which is mostly like long-term archived problems. But here, everyone's sort of doing it on the same day, which makes it more fun, I think. Yeah, he watches Twitch. He watches people solving his problems. He comes up with very clever problems as well. It looks like this year is going to be the first year where he has this rule here. No using AI, because last year people were using AI and they were basically winning, like completing the problems within like 5 seconds or something, just because ChatGPT can just do that. So yeah, that's the guy, Eric Wastel. Yeah, it's cool. I recommend it, and I'm just almost finished with this year. I'm on 24, and then if I finish early this stream, I might try and do 25 as well, just round it all off, because I'll be starting the actual 2023 in a couple of days. And you can also kind of have your own private leaderboards that people can join. So for example, like some of my viewers have joined my leaderboard here. And so I'll just put this code here if you ever want to, or if any other viewers want to join it, you can just type that in and it puts you on the leaderboard. It just shows like who's completed what problems and stuff. Right, so this problem that I'm doing right now is wordy, but it's not hard, I think. Basically, we're programming a sort of game where we've got two teams battling each other, and they've got like Dungeons and Dragons kind of mechanics. Well, not Dungeons and Dragons, a bit like, sort of, like Baldur's Gate mechanics, where you've got like hit points and initiative and immunities and weaknesses. It seems not that difficult, it's just we've got to code a lot of stuff, and we've got to work out which team wins the fight. So they're doing their attacks one by one. So, I started just by parsing the input, because we have the input in natural language, which is a bit... We're going to have to use regular expressions to extract all this information. So we've created a thing called a group. A group is basically a little army. It has a number of units, a number of hit points per unit. It has a list of weaknesses, a list of immunities, attack strength, attack type, has initiative, power is basically how much damage it does. So that's, I think, all the variables we need. Now we need to populate these groups from this text file here. So we open up the input text for each line. Okay, let's say we've got two armies. We've got the immune system and we've got the infection. Okay, so immune system equals infection equals that. So if line dot starts with this, nice to see data classes being used in practice. Yeah, this is a good excuse for me to use it, because sometimes I knew about data classes it was only introduced in the last couple of years, wasn't it? So I tried to use them, but sometimes I forget and I do the old-fashioned way, which you write your init and you have to populate these up one by one, and they're really not much more unwieldy, but yeah, this is nice. Ties things up nicely. So let's say army equals none. So let's say current army equals none. All right, so if we start with immune system, current army equals immune system. Elif if we see this line, elif not, line.strip. So if it's an empty line, just continue. Okay, so otherwise it's of this form. It looks like we need to define a pattern here. I always forget how to use regular expressions. So the pattern is going to be... Let's just copy one of these lines in. Alright, so it's going to be like... So it's going to be \d plus for the integer. Let me take a quick look at Python regex. Okay, I'll use the regex tester, regex101.com. So I can test what I'm doing as I build it. So I'm not showing it on stream. It's not important. Yeah, whatever. Just take these lines. Yeah, I've never really committed all this stuff to memory, so I always have to resort to it. So my regex is this so far. Okay, so we got D plus units, each with... Alright, let me just write it in the IDE first. So that should be D plus hit points. Okay, so star. Okay, that's fine so far. Weak to bludgeoning. Ooh, so this one's an interesting one because you may have weak to something, or you may not. So we got weak to, and then it'll be, is it small w? And then hang on, but then how do you deal with the comma? We don't need to deal with the comma in the regular expression. We can do that once we extract that. Then, so that will capture both, but it capture all of the all of the weaknesses. We'll have to extract them manually. Unless there's a way to deal with this comma. I don't know. Don't know. We'll deal that using Python split. All right, and then there's an optional semicolon space, which may or may not exist. And then you have immune to. So the same as this. I hope what I'm writing is actually works. Immune to. Then you close the bracket with an attack that does radiation damage at initiative. Oops. Let me test that now. And then we want, you need a start and stop, don't you? So like $sign, is that what you use? No, it's carry and then $sign at the end. Ah, no, I'm using the square brackets incorrectly. Match everything enclosed. Capture everything enclosed. Yeah, no. Okay, we should have... Ah, so if you want to capture the curved bracket character, you need to backslash it to escape it. And square brackets, we should be using curved brackets. So we'll do that. Is that better? No, it's not matching yet. Oh wait, I don't think that's what curve brackets... No, we're not using capturing groups. I shouldn't. It should be match everything enclosed. I see. Hang on. Okay, we've sort of got a matches, but let me try and copy that into the ID because you can't see what I'm doing here. Wait, I can switch to. Actually, it's better if I just show the screen. So. So if I take everything after here out. Okay, that matches some lines. Weak to bludgeoning. Oh, you might not have these brackets at all. That's a pain. All right. 'Alright, why doesn't it match the first line? Zero and one. Is it question mark? Is 0 or 1, yeah, okay. Word character. Does word character include spaces? Probably not. No, it's letter, digit, or underscore. Also, we want letters, not word characters. So letters, single character. Right, so we want, actually what we want is, instead of W plus, we want A to Z. Or white space. Oh, I'm making a mess of this. You know what? Maybe we should handle the immunities bit with Python because I don't know how to do this. Alright, so if I just forget about this bit here, we'll just write code in Python to deal with that. Week to so-and-so, and then it goes to... Okay, so it's going to go... Alright, so take this out. Okay, hit points, and then we've got up. Basically, this whole thing will just replace it with dot star. So dot star captures everything that may or may not be there. And then we'll have to unpack that with Python. With an attack that does 71. Radiation is actually A to Z plus at initiative 7. Okay. Units each with... Okay, so why doesn't it capture this one? Units each with an attack that does... Oh, because this whole... This thing here is... Okay. Take that space out, because we've got one too many spaces there. With an attack that does... Okay, that matches... Let's check if it matches the entire set. Yeah. Okay, so we can unpack the weird bit in the brackets. I'm not good enough with regular expressions to deal with that using regex. Okay. Pattern. It's going to be that. Invalid escape sequence. Oh, because it's in... Oh, man. You're gonna have to... Every time you do a backslash, you have to put another backslash. Is that right? There we go. Everything else should be fine. Is there a way to do it without having to escape the backslashes? Because it's kind of confusing. Alright, doesn't matter. We've got the pattern now. Alright. So... How do we deal with this? We want... Alright, which method do we want to use? Python regex capture matches. We want to capture the... Right, so we use re.search. Oh! Also the pattern should be R... like that. And here... Then we don't have to backslash. Yeah, okay, that's how you do it. So we want re.search pattern with line.strip. Okay, that gives us a match object. Now we want to print the groups. See what that gives us. Does that give us the individual elements? No. The price. Let's just use the original Python documentation. I don't understand these examples. I think by now I could have just used Python to code this, but I'm trying to actually do this. I think we should be using match. Not search. Okay, and then just print match equals one. Okay, but it's matching that entire string. But how do I capture the individual? Do I just put brackets around them? Is that all? There we go. Yeah, I forgot you have to put brackets around the capture groups, so... And then we want... That's an optional capture. There we go. And if there's nothing in there, just put an empty string. Okay, good. That can actually get us somewhere. All right. Okay, just say G equals, just say M equals RE.match. Now, we need to populate the group. G equals group. So how do we do this again? We go units equals m dot group. Starts from 1, doesn't it? Not 0. Int. Let's test this out. Print g.units. Okay, that works. 956. Okay. Okay, so units is there. Hit points equals. So it's going to be mostly like this. Weaknesses. We need to sort this out before we do this line. All right, so S equals, let's group 1, 2. So the third group is this thing here. Weaknesses equals empty list. Immunities equals empty list. All right. So if not, if S, right? So if there's actually any content in there, then there will be an open bracket and a closed bracket, so we can ignore those. We want to do parts equals S from 1, so ignoring the parentheses, dot split on the semicolon space. That will get us, so the left half will be weaknesses and the right half will be immunities, if we even separate them like that. Okay. For part in parts. Okay, so each part will look like weak, or it will say either weak or immune, 2, and then a bunch of stuff. Oh man. Okay, if part dot starts with week 2. All right, deal with these separately. Then weaknesses equals part. So it'll be 8 onwards. Dot split, and then we want to split on the comma. Comma space. Elif part that starts with immune to, then immunities equals, so it'll be ten. Is that okay? Otherwise they just get left as empty strings. Alright, so we carry on this. So hit points equals that. Weaknesses equals that. Can we just... how do I just... I don't want to have to... Okay, just go to the next line. Immunities. Hello, Zen. What would this be anyway? So we're trying to code a... The problem is a small little game, basically, where we have two... It's kind of like, I don't know, like Baldur's Gate kind of mechanics, where you have opponents and you have like strength and immunities and initiative and stuff, and you're letting them fight back and forth until one team wins. Yes, basically, yeah, like Fallout Tactics, or, well, yeah, a bit like Fallout games. It'd be more like Baldur's Gate because it's got initiative and stuff like that. Dungeons and Dragons rules, basically. Well, Fallout does have initiative, I guess, yeah. So I've kind of got the trickiest bit out of the way. Now we just need to extract the remaining stats. So we've got attack type equals m.group 5. And then finally, we've got initiative equals into group 6. So that will give us all those variables. So our input comes like this. It's natural language, which is a pain to... we have to use regex to unpack all this stuff. Once we've got it, we've got, in programmatic terms, we've got an army. What do we want to do? We just want to put that army in our list. Current army dot append G. So after this is all done, we should have 2 armies. Immune system. Infection. They should each have... bunch of groups. Oh yeah, and that's the nice thing about data class is they already know how to print all this stuff, so you don't have to write your own print methods and equality methods and all this stuff. I used to do this, still having bit traits of knowledge. Yeah, it's quite fun to deal with, and it extends well to software engineering because you do stuff similar to this where you've got all classes with a bunch of properties and data properties and. So let's see if this actually works. Oh. We're including an extra character here, wait. That should be -2, because we've got an extra space. Try again. Alright, let's have a look. There we go. Broadening, slashing. Make sure it's all correct. So we've got units, hit points, weaknesses is a list of strings, immunities could be empty. 71 attack radiation, H56 group. Yep. Looks good. Wow, that was probably the hardest part of this. Now what? We actually have to do the fight. So let's look at the rules for this fight. Quick run test. Yeah, well that's the result of the run test. I haven't got any code for the fight, so we have to code that. But we've got our armies stored in that list. Stop printing that as well. Right, so I have to split this up into phases. So each fight consists of 2 phases: target selection and attacking. All right, when does the fight end? The fight ends. Combat only ends once one army has lost all of its units. Okay. So, while immune system and infection, i.e. there is stuff in both immune system and infection. Are you done with the story script? I want to know Premi's spoiler bit. There's not much of a story for this. Well, the story that we're given is... Well, I could just link it here. There's a little bit of flavor story, but it's not much. Something about a reindeer has a cold and we need to fight the cold using the reindeer's immune system. That's it. That's the whole story. It's like 2 lines of story. Right, so... Each fight consists of 2 phases: target selection and attacking. Alright, so the first phase is target selection. Okay. Target selection. So we have to go through... Alright, we need one more property here, because these groups don't actually know which army they belong to. So, we're gonna have to have army. Wait, let's think. We don't care about what army we're in, we just care about what army we're fighting. Enemy army equals enemy army post-apocalyptic themed. Enemy army is a group. It's a list of group. Are we not allowed to do this? Have group defined within a group? I guess not. Should just say it's a list then. Okay. Enemy army equals well, well, we're gonna have to define it up here, aren't we? Just call it enemy. There we go. So now each group knows what their enemy is, but they don't care about their allies because you don't do anything with your allies. You don't like heal them or anything. Okay. Okay, so back to this. Target selection also. It's getting cold. Wait, turn the AC off. Target selection. So what did they say? They said, each group attempts to choose one target. In decreasing order of effective power. So we need to take all the groups both sides, all the groups from both armies, and order them by effective power and initiative. Highest effective power and initiative, okay. So we need for group in. So it's gonna be so we take immune system plus infection. Hang on. So they're each gonna choose a target. Okay. Okay. We're gonna need to give them a target. Target will be a group. Okay, so we want to take immune system plus infection. We sort it. Key equals lambda G. So we want to take the effective power as the first parameter, and the second parameter G dot initiative. And we go backwards. So we start with the highest effective power and then initiative and work backwards. Okay, so for this group is going to decide on his target. So he... Oh man, this is so confusing. We need another variable. Is targeted. Ooh. Because if you target someone, then no one else is allowed to attack them. So that opponent needs to know that he's being targeted, so that no one else can try to target them too. Okay. All right. So now it looks at all the enemies. I want to find the enemy that he'll do the most damage to. So we're gonna need to work out damage now. See if this runs. Oh, it's gonna go infinitely. Stop, stop, stop. Okay. Okay, let's compute damage. Right, this is a group method. Get damage. Alright, how is damage computed? So damage in general is just your effective power. It's just this. But if the other, okay, so if other dot, if self dot attack type in other dot immunities return 0, you do no damage. Elif self dot attack type in other dot weaknesses return, or let's say base damage equals self dot get effective power, run 2 times base damage, else return base damage. That's how damage is computed. Alright, so here we've got a group. We want to find what he can target. So viable enemies equals E for E in group dot enemy army if E dot targeted is not none. So that's saying we're filtering this to only the enemies who have not already been targeted. Okay. And then we want if there's no viable enemies, then we continue. Okay. So we want to choose the group we deal the most damage. All right, so target equals Target equals the max viable enemies. Key equals lambda e. So it's going to be the most important parameter is group dot get damage on E. And then we break ties with enemy's effective power. And then we break further ties with initiative. Because initiative is unique, there's never any pure ties, okay? Okay, so we've got a target now. If group dot get damage on target is strictly greater than 0, because it might be 0. Then that's it. We've chosen our target. So we have to do group dot target equals target, and target dot is targeted is set to true. Okay. Let's just try running that and then break out of this loop. All right, so group has no attribute targeted. Is targeted. And that's a bool. Okay, so far so good. Now we move on to the attack phase, which I think is actually simpler. So now each group has selected 0 or 1 groups to attack. Okay. And being attacked by 0 or 1 groups. All right, during the attacking phase, each group deals damage to the target it selected, if any. But if you lose attack, if you've lost units this round, then you can't attack. Okay, so all right, so okay. So it's this line again. For group in sorted immune system plus infection, but this time we're just going in order of initiative. Starting with the most initiative and working down. All right. Okay. First of all, if group dot units is less than or equal to 0, skip this group because he's dead. He got killed earlier, so he can't carry out his attack. Okay. Group.units or group.target is none. Continue, because he's got no target. Okay. The number of units lost equals it's going to be, so we need group dot get damage against group dot target divided by group dot target dot hit points. Yeah. So we're trying to kill the maximum number of units, so you just divide evenly by the number of hit points. And the leftovers get rounded down, so you only kill... If you do 55 damage and they've each got 10 HP, then you kill 5 units, and the extra 5 damage is wasted. So group... So then group dot target dot units minus equal units lost. And if they've gone negative, then they'll still come up in this list because we don't want to mess with this list. But yeah, they won't be able to carry out their attack. Oh, this is wrong here. That should be not. We don't want to target anyone who's already been targeted. Okay. Alright, so at the end of this attack phase, everyone's carried out their attack. Some units, some groups might be dead now. So we need to filter them out. So... immune system equals G for G in immune system if G dot units is greater or equal to 1. So we just replace it with all those units, all those groups which still have units. Alright. What else? We need to reset the targets. For G in immune system plus infection. G dot target equals none. G dot is targeted equals false. Targeted is 1T. I gotta look this up now. Yeah, it's 1T. Is that it? Anything else we need to clean up? Hit points never changes. All this stuff never changes. Enemy army will always... Yeah, okay. So if we run this, it hopefully will work. What is the end result we want? How many units would the winning army have? Okay. Print length of immune system. I'm guessing the infection is going to win, because we might... Then part 2 will be something about improving it. I don't know. 0 and 10. So 10 is the answer. That's... That doesn't sound right. That means the entire army survived. It's possible, but I don't think that would really... That's what they were going for? I don't know, let's see. I think some groups would die at least, wouldn't they? What? Why is this so big? Okay, units. Go stop printing stuff. Okay, just go to the top. So got unit 6833 left. (913). So we have lost units. Oh! No, you are summing the units. Okay, so you're not just saying 10. Because I was thinking that would be stupid, then you could just guess 10 and get it right. You want to print sum of g.units or g in infection. $15,392. Correct. Okay, so that code seems to be fine then. Part 2. Things aren't looking good for the reindeer. The man asks whether more milk and cookies would help you think. So yeah, the infection won and they didn't even lose any groups at all. If only you could give the reindeer's immune system a boost, you might be able to change the outcome of the combat. A boost is an integer increase in immune system units' attack damage. For example, if you were to boost the above example's immune system's units by 1570, find the smallest boost that allows the immune system to win. I could do this programmatically or just try numbers. I'm too lazy to do this programmatically. Let's because then you'd have to reset the groups. Let's say boost equals 1000. Alright, so the question is how many units does the immune system have left after getting the smallest boost it needs to win? So we need that first number to be not 0. So if we say boost is 1,000, then attack, we just have to change attack to be... Oh, I didn't switch back to... We just change attack to be plus boost if plus boost if current army is immune system, else 0. So we just add an optional boost. So if I add 1,000, let's see what happens. The immunity wins. Alright, let's decrease that to 500. Immunity wins. 100. Immunity wins. Wait, are we... Am I doing boost correctly? Let's check this. Boost. Integer increase in the immune system unit's attack damage. Yeah, I think I'm doing it correctly. It just seems it's very effective. 50 then. 1865, okay. 30. Okay, we lose. 40. We lose. 45. What's going on? Is it hanging? What's happened? Boost equals 45. Why is it stuck? Boost equals 45. It gets stuck in a loop. What the heck? Try 46. We win. 44. We lose. What happens with 45? I reckon we get into a situation where nobody can actually win. It's a stalemate. Because nobody's doing any damage. That's actually possible. If you're immune to your opponent and they're immune to yours, then you'll never do any damage to each other. It'll go on forever. So 45 is a stalemate. So the answer to the original question, the smallest boost needed to win is 46. 44, we lose. 45, it's stalemate. 46, we win. And if we win, we get 1,092 units left over. Seems correct. Correct. So interestingly, So if you were doing that programmatically, because I was being lazy, if you're doing that programmatically, you would use binary search, I guess. But you'd have to account for the stalemate, so you'd have to make stop the fight as soon as you realize you've gone through one round and no units were lost. That's easy to check. You just keep a boolean. As soon as a unit is lost, you set that boolean to true. Otherwise, you leave it as false. So if that remains false by the end of the round, then it's stalemate. Because if they don't do any damage this round, they can never do damage, right? Probably. Alright, that's not a hard problem, but I imagine it just means it's just a problem where you gotta code all that logic there. That is a lot of logic. But it's not hard at all. There's no algorithm needed, really. This is a good problem, actually, because this is reflective of the kind of stuff you do in the job. Just very wordy descriptions given by your higher-ups who don't really understand code, and you've just got to translate it into something that's actually relatively simple and not even that complicated, but it's just handling the data correctly. That's totally an industry kind of problem. All right. The big question is, do we finish Christmas Day today? Umara mentioned that Christmas Day 25 might not be that hard. So, and it's only going to be part 1. Should we go for it? Tell you what, I'll at least read the description fully and decide if I want to go for it. Because we've got time. All right. Four-dimensional adventure. The reindeer's symptoms are getting worse, and neither you nor the white-bearded man have a solution. At least the reindeer has a warm place to rest, a small bed near where you're sitting. As you reach down, the reindeer looks up at you, accidentally bumping a button on your wrist-mounted device with its nose in the process, a button labeled Help. Hello and welcome to the Time Travel Support Hotline. If you are lost in time and space, press 1. If you are trapped in a time paradox, press 2. If you need help caring for a sick reindeer, press 3. Beep. A few seconds later, you hear a new voice. Hello, please state the nature of your reindeer. Just a moment, I think I can remotely run a diagnostic scan. Okay, it looks like your reindeer is very low on magical energy. It should fully recover if we can fix that. Let me check your timeline for a source. Got one. There's actually a powerful source of magical energy about 1,000 years forward from you, and at roughly your position too. It looks like hot chocolate. Anyway, you would be able to travel there to pick some up. Just don't forget a mug. Is there anything else I can help you with today? You explain that your device isn't capable of going forward in time. I see, that's tricky. Well, according to this information, your device should have the necessary hardware to open a small portal and send some hot chocolate back to you. You'll need a list of fixed points in space-time. I'm transmitting it to you now. You just need to align your device to the constellations of fixed points so that it can lock onto the destination and open the portal. Let me look up how much hot chocolate that breed of reindeer needs. Just skip a bit of this story. Oh, okay, what did it say? This can't be right. It says there's only one like that in the universe, but that means you disconnect the call. Alright, the list of fixed points in space-time is a set of 4-dimensional coordinates. Alright. To align your device, acquire the hot chocolate, and save the reindeer, you just need to find the number of constellations of points in the list. Huh? Okay. 2 points are in the same constellation if their Manhattan distance apart is no more than 3, or if they can form a chain of points, each a Manhattan distance no more than 3 from the last between the two of them. Ooh, so is it really just breadth first search? How many constellations? How many stars do we have? That many, okay. It's basically depth first search, isn't it? Because we don't need notion of distance, we're just trying to find all connected sets. Is that right? Okay, I think I get it. This is not hard. This is textbook problem. It's get all strongly connected components. Just run breadth first search multiple times. Nice straightforward problem for Christmas Day. All right. So we want points dot pans line dot. So it's going to be line dot strip dot split comma. It's going to be tuple int x or x in that. All right. Print points. Okay. So define dist p1, p2. It's going to be return the absolute value of p1i minus p2i, and it's going to be sum of those absolute values for I in range 4. Define I think, okay, we want to make a neighbors list. That will help here. Let's say edges equals p to the empty list, or I don't know, set, an empty set for p in points. So we're just creating the edge, the neighbor set for each point. A neighbor means a star that's within distance 3. Okay, then we go through all the points. So for P in points or Q in points if P equals Q. We can skip this one. If dist of PQ is less, so what was it again? Is less than or equal to 3. That's quite tight. They need to be really close. Then edges P dot add Q edges Q dot add P. Print edges. So that should be the edge list. Eight, 4, minus 4, minus 4, minus 5, 7, 5, 4, 6, 7, 4, 4, 6. Yeah, that looks right. Okay, so that is the bulk of the work, because that's 1,000 times 1,000. That's 1,000,000 operations to find all the neighbors. But now that we've got that, we can more rapidly check neighbors without doing all that. Okay, so now we want chain count equals 0. Point set equals set of points. All right, so while there are still points that need, so the idea is in each iteration of this, we take a star and we just do a depth first search to find all stars which are connected via chains. We remove them all from point set and increase chain count by 1. And just rinse and repeat. Okay, so start equals lists. This is kind of a hacky way to get an item, arbitrary item from the list. I don't know a better way. Let's just do this. Start equals that. Q equals start. So that we're going to do breadth first search. So while Q. So we then we go through the neighbors and all the ones which are still in point set, that means they are ones which we can go to, and then and if they're not, then they belong to other chains. Okay, so while Q current equals Q.pop, just arbitrarily take an item off the list. we want to remove this from the point set because this we never want to deal with this star again. So point set dot remove current. Okay. Neighbors equals, it's going to be edges. So we go for neighbor in edges of current. So these are all its neighbors. If neighbor actually, tell you what, let's remove start here. Okay, so we don't do this. Okay, so every time we put something in the queue, we take it out of the point set. That avoids it ever being put back in the queue. Okay. Alright, while the queue has stuff, we take an arbitrary item from the queue. Alright. Now for each of its neighbors, if this neighbor is in the point set, then we have to remove it. So we take it out of the point set and put it on the queue. The idea is the queue is just the chain. Point set dot remove. Now this can't go in an infinite loop because every time you add a neighbor to the queue, you remove one item from the point set. So we can't get stuck in an infinite loop. We don't want start, we want neighbor. And then after all of that is done, we just increase chain count by 1. That means we found one chain and we removed it from the point set. So ultimately, whatever chain count is, should be the answer. 394. Correct. I solved that way quicker than a lot of problems. So that ended up being actually one of the easiest problems of the lot. That's a nice Christmas Day surprise. Part 2. A small glowing portal opens above the mug you prepared, and just enough hot chocolate streams in to fill it. You suspect the reindeer has never encountered hot chocolate before, but seems to enjoy it anyway. Oh, let's close the regex. You hope it works. It's time to start worrying about that integer underflow in time itself you set up a few days ago, which feels like a lifetime ago because I started this a few months ago. You check this... Oh no, this is referring to day 21. Yeah, I don't remember the story anyway. You check the status of the device. Insufficient chronal energy for activation. Energy required 50 stars. The reindeer bumps the device with its nose. Energy required 49 stars. You have enough stars to trigger the underflow. But we have 49 stars. You use all 50 stars. Hey, wait. That's a... But we don't have 50 stars, we have 49. So how can we use all 50? We rigged the system to allow us to use 49, but we don't have 50. I've uncovered a plot hole. As you begin to fall, the little reindeer looks up at you. Its nose begins to glow red. You go back in time so far that you wrap around and end up back in your own time again. Oddly, history books contain some new details that you don't recognize. The Easter egg thing is a nice touch, but I never really actually go back and look for all the Easter eggs. But it's like when I've done it, I just don't feel like going back. But there we go. Completed 2018. Oh, this was day one. I don't even remember anything from this. This was a couple of months ago. There we are. Got hot coffee. We've got chocolate. We've got sleigh. We've got luggage in space. I don't remember what that's about. Oh, that's a cup. Got reindeer. It was Rudolph after all. Have a look at the stats. So 24. Okay, part 2 was easy. Not many people got stuck on part 2 for that, but it was kind of same difficulties before in terms of completion rate. And then 25. It seems people found it difficult. I thought that was actually very easy. That last one, that was just like that was just breath first search. I'm surprised. That only. So 3916 is both parts, and 1754 is. Ah, okay, so that's actually more like 5,700 if you add those together. Because you only get the second part if you've done all the previous parts. So let's just ignore that factor, add them together. You get about... That's more than previous. Yeah, okay, so that makes it sound like it's actually easier. Not by much, though. I would have expected a higher completion rate for part 1. But... Alright, anyway. What was this one? Okay, cool. That was an interesting year. There were quite a few assembly code problems thrown in there, which in principle are good problems. They're clever problems, but they're also... I have to admit, I don't like the fact that you have to remember... So in this case, there were like 3 or 4 problems which are all continued from one... So you had to have done all the previous ones in that list, or at least understood the description, but I'd say you pretty much would have had to solve it to continue that sequence. So normally, you know, I tell people that if you're stuck on a problem, don't worry, you can just try tomorrow's problem independently. But that's not always true, because in the case of these assembly code problems, you actually needed to have done the previous problem. So I don't mind that so much, but it kind of does break the contract of the idea that if you get stuck on a day, then you don't have to worry about that day, you can move on to the other days. So I have mixed feelings about that. I imagine a lot of people just don't like the assembly code problems. I've seen that sentiment a few times. Some people like them. I'm on the fence, I guess. They are clever problems, and I think they do test valuable skills in your ability to interpret the semantic meaning of programs, which is not something that you test much in these problems, but because they need you to do investigative probing. You can't just write a problem which takes an input, spits out an output. You actually need to kind of understand exactly what your program is doing and provide your own human input, which is actually something that doesn't get tested enough, I think, and it's a very valuable skill, because half the time that's actually what you're doing when you're a software engineer. You're not just writing textbook methods, you are actually kind of tailoring your piece of software or whatever to your customers, or trying to debug a certain problem. 2 minutes 16. But all these people had already solved all the previous problems. So some people... 2 minutes 14. Oh no, it's the same guy. So it took him 2 seconds to solve part 2. So that means he had to click the things really quickly. So it took him 3 seconds to solve part 2. 246, 249, 3 seconds. So solving part 2 does take 2 to 3 seconds because you have to click a couple of times. That's funny. But yeah, that's believable. 2 minutes. It was... If you know your breadth as such, you can write it pretty quickly. I couldn't write it anywhere as quick as that, but... See, look at the disparity here. 24, 25. This was 28 minutes. This was before ChatGPT, so... You know, now that there's ChatGPT, this is something that ChatGPT would excel in. An easy problem, but just takes a lot of translating language into code. ChatGPT would turn that into seconds, but it would struggle at certain other problems where you need to be smart, i.e. the assembly code problems. So yeah, look, this actually... Oh no, 17 took longer. 15 took longer. It seems that 15 was actually the... Not necessarily the hardest, but the longest to code. What was 15? Oh yeah, the goblins and elves. That was actually fairly hard as well. It's very easy to fall into traps here. Yeah, if you're coding a game, it's not textbooky. It's a fairly original piece of scripting. So yeah, that's gonna take a while. So no surprise that this took half an hour, and so did the today's one. All right. Well, that's good. So that means tomorrow I get a free day. I don't have to do any advent of code. But then the day after, we're gonna jump right into the real thing. Oh wait, but if I want to do it at midnight, if I want to do it the moment the problem opens, it's actually gonna have to be tomorrow. So I don't even get 1 day of break. Midnight EST. Can I change the time zone to be my time zone? I don't know. Okay. Alright, well, how long did this stream take? 2 hours to solve those 2 problems. That's alright, I guess. So yeah, that wraps up 2018. So if you've been watching that, if you want to solve these problems yourself and compare your star collection with me, it doesn't show much, it just shows whether you've solved the problem or not, then you can join this leaderboard. Oh, have I crashed the site? No stats. Oh, no, we want to change to 2018. Oh, and I still need to do 19 and 21 next year. 2018 leaderboard, private leaderboard. Yeah, you want to use that code there. And you can join the leaderboard here. Patagonia has solved some of the past years, but I don't think they've tackled this year yet. Umaro will be participating in year 23. I guess he won't have time to do any past problems. Okay. Nothing more to say then. That has been Advent of Go 2018. And if you're watching Eric, well, shout outs to Eric, who's done a great job with this site, and it continues to be, in my opinion, the best such site of its kind. I don't know of anything better. The interface, just the look of it, is nice, clean, and easy to use. The problem with a lot of other sites is that they're made by these big companies that are really focused on selling interview products and enterprise products. And so their website really is, the actual competition is usually buried somewhere in their site because they don't actually care about it. They're mainly trying to sell a product. Eric isn't trying to sell a product here. This is the product. Just this Advent of code for everyone to enjoy. Yeah. And maybe I might donate just before next month starts. I'll look into how to do that. Shop. What do they actually sell? It's a nice idea, but I live in Thailand, so none of this is going to get to me easily. But okay, nothing more to say. I'll see you in a couple of days with 2023, and I hope you code along with me. Goodbye. See you.